Hello, welcome back to Capstone Design. Today we're going to talk about another ideation method called Transformational Design Methodology. It's a really powerful tool for creating systems that are compact and share functionality. I'm going to share my screen real quick. So at this point, your team should be getting pretty good customer needs and requirements, and you should have started ideation so that you can start getting some good designs. There we go, screen number 3. And this is just adding to that. This method is another tool in your quiver that you can use to add to your list of concepts that you're going to eventually refine and turn into your final design. Okay, so moving along here. So just to summarize, there we go. These are the ideation techniques we've talked about so far. We did design by analogy last lesson, and now we're doing transformational design. Okay, so a transformer is a system that exhibits a state change in order to facilitate new or enhance existing functionality. And our lives are full of transformers, whether you realize it or not. I'm going to show you a couple right now that I think are pretty cool. Here's one. This is my the Emperor Palpatine's spaceship. And of course, if I turn this dial, the wings fold up, or fold down. So this allows us to have different flight characteristics. So of course, in the military, we have aircraft like this. The B-1 bomber, it can sweep its wings or extend its wings for either higher speed flight, lower drag flight, or higher maneuverability. This one's really neat. I got this in Afghanistan when I was deployed there. This is an interesting, kind of decorative basket. But the way this works is these can fold down, and this is all made out of a single piece of wood. And it's pretty cool. They use a scroll saw and cut in a spiral so that this has it utilizes the natural flexibility in the wood, and this can pivot. And we've got a little pivot here for a stand. So that's pretty cool. These were very common in the Middle East when I was over there. And we'll talk about some of oh yeah, this one's one of my favorite transformers. This is my mountain bike helmet, so I wear this with this chin guard when I'm going to go huck myself off of 30-foot jumps at the mountain bike park at Winter Park. But if you just are doing a less intense ride, you can remove this chin guard, and you've got a more comfortable helmet to wear for, like I said, a less dangerous or less intense ride. So that's a pretty cool product that's only just become available in the last couple of years. So we'll talk about a lot more transformers here in the coming slides. My goodness. I'm feeling my computer might restart. I hope not. All right, so what are the benefits of transformation? Well, it allows us to accomplish several functions, or maybe accomplish several missions in a single device. So we can potentially reduce cost, or reduce storage requirements, or reduce what we have to carry. So in those cases, it can be extremely beneficial. In some cases, you actually get value out of the transformation itself. You gain a function that you couldn't do with two separate products. So an example of that is this bicycle shown here, this red bicycle. The way the design works is as the vehicle speeds up, those rear wheels come together. Oh, I forgot. I just realized I'm not sharing my screen. So let me fix that. What I'm describing, and you'll see on the slide as soon as I get this up. Okay, you should be able to see my screen now. I don't think you missed anything on the last slide. Let's double check. So this was the previous slide. Of course, these slides are always going to be posted on the team's page. So take a look at this transformer here. It's an interesting design for a bicycle. It has a single front wheel, like a typical bicycle. At low speeds, the wheels are folded out and it's a tricycle. So it provides stability for a beginning rider and also makes it easier to get up to speed. As the vehicle speeds up, those wheels come together and they actually flare out, so there's only one contact point at the bottom, and that provides a more realistic bicycle riding experience. So it's a great device for helping train people how to ride a bicycle who've never done it before. Okay, so how do things transform? So as designers, we aspire to be able to design things, invent things that use transformation. It's helpful to understand how existing products transform or how other objects in nature transform. So about 10, 12 years ago, researchers at the Academy and University of Texas studied this. We studied transformation. This project was actually sponsored by Air Force Research Lab, and they were interested in this. And studied thousands of products and determined that there are basically, in the mechanical domain, there's three main ways that objects transform. They either expand or collapse, they fuse or divide, or they expose or cover surfaces. In addition to those main three principles, they identified 20 facilitators that allow for the transformation to happen. And we'll talk about those in the coming slides. Okay, so I mentioned these three main principles: expand, collapse, expose, cover, fuse, and divide. And then if we expand the slide, you'll see the various the various facilitators that help make that happen. So this first row are the main facilitators. So what do I mean by that? So for the fuse divide principle, a facilitator that helps facilitate something fusing and dividing is that there are modular parts. Okay, a modular means you can attach something and remove it, and that this bike helmet I just showed you is a modular system. It's got multiple components. You can bring them together and get different functionality. There's many examples of this in the real world. So there are various facilitators, like I said, that help with the transformation. And these are broken down in there. You know, at our level here, it's not critical that you get really in depth with those. You'll see how these come into play in a moment. So let's take a look at each of the principles in turn. The first one is expand and collapse, and you have used products like this your whole life. Okay, so the folding camp chair is a great example of something that expands or collapses. Why do we want it to expand or collapse? Well, it allows for easier storage, easier transportation. Very helpful. This is a really interesting analogy from biology. The pufferfish, it expands not for storage, but to scare off predators, and makes itself look bigger. And then it collapses so that it can be more streamlined and can more easily travel through the water. And this is an interesting design for a beach blanket that you fold out and you throw all your junk on it, and you can fold it up, and it acts as a tote bag. So that's expand and collapse. Here's a really cool example from nature. This is a wheel spider. It can fold up its legs and make itself into a ball and roll down sand dunes, and then it can pop out and run away. Pretty cool design. You might think about that if you're thinking about how to make something move. Say you're designing a robot and you want it to have some precise motion, but you'd also like it and agility, but you'd also like it to be able to move fast. Could you design something that crawls like a snake, but when it needs to move fast, it can roll up into a ball or a cylinder and then have the ability to roll? Be a pretty cool capability. Okay, so the next one is expose and cover. This one's a bit challenging, harder to understand. So this is a cool example. This is a chair that can fold and form a ladder. And so what we're doing here is by folding the chair, we're exposing a surface that wasn't available before, and the surface are these 5 steps. Another example from nature is the lily pad. It exposes that green surface, which allows it to collect light from the sun and do all that cool chlorophyll thing. All right, here's an example of a folding keyboard. I don't know if any of you have these. I have one of these for my phone. It can plug into your phone or use Bluetooth. And by unfolding, it exposes the keys. And when it folds up, it covers those keys so you don't get accidental key presses or something like that. You might have maybe a cover for your phone or a cover for your iPad. Obviously, I have my laptop. It folds and covers the keyboard so I don't damage the screen or damage the keys. Okay, the final principle is fuse and divide. This one's extremely common. Here's a simple example of a fusing and divide device. So it's a screwdriver. And on the back here, I can expose a chamber that holds various bits, and and I can divide and then fuse a different bit on there, and I'm able to have multiple tools in one device. Now, what's going to come next is you might think about what facilitates this transformation. Well, this in particular uses the facilitator we call common core structure. So it's got this shaft, this handle that's common to all the different types of tools. And I remove and exchange bits with this common core and create the different tools. Here's another fuse and divide device I like. This is a hiking pole. It's carbon fiber, very lightweight. I can pull it like this, and it makes a really strong, lightweight hiking pole. Use this all the time. So those are some examples of a fuse and divide device. On the slide, we see a great example from nature are these army ants. They can work together to create a bridge and use that to overcome large obstacles. I think about how something like that might apply to a Capstone project. We have a team this year, the munitions team, whose goal is to create fusing and dividing weapons so we can get longer standoff range from our long-range strike weapons. Okay, so let's talk about facilitators now. These are different than the principles. These allow us to do the transformation. So I just mentioned one already, and that's the one on the slide. I'm not going to talk about each one. There's over almost 24, but one that's very common is this one called common core structure. So I gave you that example already with the screwdriver. Another good example of a common core structure transformer is the cell phone. Now, you might look at that. That's my family on the Tetons. You might not think of a phone as transforming because it doesn't physically change its shape. But what we have here is a common core that facilitates the use of multiple apps. And so the hardware is common, and it has different sensors and actuators in there that are available for use by the apps. And the apps access those different capabilities and create new functions. So there's a phone function, there's a map function, there's a texting function, there's a camera function, et cetera, et cetera. And they all benefit from that common core structure. Here on the slide, we have this leaf blower slash vacuum. So it can blow leaves, it can suck them up and put them into a bag. We have the wasps or bees that, or these are actually termites that have different modalities throughout their life. And a butterfly that starts as a caterpillar is similar to that. Okay, so this is a different chart showing all the different principles in green and the various facilitators in blue and gray. And you can see how those work together. Some of the facilitators overlap. So generic connections can facilitate an expand and collapse, or it can facilitate a fuse and divide. Okay. In any case, these provide many different functions. There might be relationships in here that aren't identified on the slide. Okay, so just to review, there's three main principles for how things transform: expand and collapse, fuse and divide, and expose cover. If we're doing this in class, we'd break up for an exercise and we'd try identifying what the principles are in various products. Here's one to think about. So some of you, maybe climbers, may have seen this before. This is it's called a spring-loaded camming device. It's for rock climbing. This was a revolutionary invention when it came out. Prior to this, climbers would have different sized wedges that they would stick in a crack. So you had to carry an assortment of different sized wedges, and when you needed to get an anchor in a crack, you would pick out the right size and try to jam it in that crack and then clip your rope to it. With this device, it can change shape and accommodate different sizes of cracks. And so that really helped climbers make it much easier and safer to climb. We'll talk about that again in a second. Okay, so what you're wondering now is, okay, that's great, Dr. Anderson, how do I actually use this technique? And so we'll talk about that in a second. In general, what's very effective is to create a mind map with these principles in mind, and I'll show you one in a second. And then we also have these things called transformation cards, transformer cards, that will help facilitate your ideation. So the goal of the technique here is to create transformational designs. All right, so here's an example of a mind map. And in this example, the design team just placed the goal of the vehicle in the middle of the mind map. They want something that has the maneuverability of a motorcycle, but the advantages of an ATV and of its ability to carry more load, drive in reverse, and be stable at low speeds. So then they placed the main three transforming principles in the main nodes, and then worked as a group to ideate on different ways that could be done. And so those are examples there. And you can look at the different ideas here. So for expand and collapse, they have wheels expand. And so that would, if you had a motorcycle with expanding wheels, you would get more stability. Expose and cover, you could expose tracks with artificial terrain. So you can increase your traction. Okay, so here's an example of a concept that resulted from that. So using the fuse and divide principle, you have a vehicle that, similar to the bicycle I showed early in the presentation, those wheels can come together for high speed and agility, and then they can open up and shift apart for greater stability. Here's an example of a transformer. It looks like a quad rotor and fly like a quad rotor, and the blade goes down, and those propellers turn into wheels, and it can drive like a normal vehicle. Okay, so if you're considering using this design technique, you want to establish first if your project is right for transformation, if a transforming concept would be valuable to your problem. So you want to consider, is your solution a transformer or a monomorph? A monomorph is something that does not transform. It has primarily one function. So these are the various definitions. If you have something that's prone to transforming, you want to use the transformation methodology, which I'm going to describe in a moment, or do the mind map that I described. If it's a monomorph product, you would use traditional methodology. Okay, well, how do you tell if you have a transforming product or a monomorph? Great question. Well, let's talk about that. In this research, we've identified that there are a number of indicators that tell you if you have a transformer or a monomorph. So there's 4 indicators to indicate that transformation would be beneficial, and 5 to indicate that a monomorph would be preferred. So let's talk about the monomorphs first. So a device that uses aperiodic use, and you can't predict when it's going to be used, when it's going to need to be available, should be a monomorph. So this great example is a wind turbine. You don't know when the wind is going to pick up. So you want that wind turbine to be ready to capture wind whenever the wind starts blowing. If it's transformed into some other shape and a gust of wind comes by the time you've realized it and transformed back into a windmill, you may have missed it, it's too late. So you wouldn't want to use a transformer in that scenario. But something that always has to be ready. If you got something that is going to detect something. All right, if something is performing a vital function, it should not be a transformer, because when you make something a transformer, you're adding risk, you're adding complexity. So you want to make sure your device is specifically designed to do the very important task that it's been designed for. When something needs to be very low cost, you should avoid transformation. Transformation usually adds complexity, it adds parts, it adds cost. So if you can get by with something that does a simple function and can be low cost, you want to do that. So disposable cups are a great example of that. Although I will say they do make disposable coffee cups that have the little handles on them, but they're more expensive. Okay, when multiple functions need to happen in parallel, so parallel multifunction, you don't want to use a transformer. Okay, so imagine a multi-tool like a Leatherman it's got the knife and it's got a screwdriver and it's got tweezers. If you need to use a knife and a screwdriver and tweezers all at the same time, you need separate devices to do that task. If you can use those, if you can use those items in series or in sequence, then a transformer is a good idea, and that will come up in the later slide. So another example from the slide is the dashboard on a car. Imagine if you had to change modes while you're driving in order to be able to see the speedometer and be able to see out the window and be able to see if your oil is getting too hot or if the temperature is getting too hot. You had to keep cycling through these different screens. That would be less than ideal. You want to be able to see all those functions at the same time. Finally, the last one is if there's limited opportunity for instruction. And so this example here is a defibrillator. A defibrillator needs to work in an emergency, and we don't have time to train you on how to select the right function or get to the right function. So it's better to have that be a single item that only does one thing. Okay, well, when should things be transformers? So these are the indicators that show when something is right for transformation. So when there's a shared function. So I mentioned, I gave you an example of that already. A screwdriver has a shared function. We need to have a handle. We need to be able to impart torque and axial force so we can share this core structure and change out parts. This slide shows an example of a shoe. When something needs to adhere to a variable, and that's some fancy words that's maybe not completely clear, but we're talking about when something needs to adjust its size. So I gave you the example of the rock climbing cam. This is a perfect example of that. If we can have a product that can change size to accommodate different size cracks in the rock, that's a good opportunity for transformation, and that's what's going on here with this camming device. On the slide, we see the example of you need many different size wrenches in order to do a job, and you don't need to use them all at the same time. Then a crescent wrench, an adjustable wrench, is a great idea. So you can just have the size of the wrench transform. When storage is an issue, you want something to be smaller or compact, then transformation is a good idea. So obviously my hiking pole, I don't want it always to be 4 feet long. That's not very convenient. I can shove it in my pack when it's folded up, and that's much better. If the job you're doing, the mission you have adheres to a sequence, then transformation is a good idea. I mentioned this before. If you can do the functions one at a time in series rather than in parallel, then something can be a transformer because you can use it for different things. It doesn't have to be used. You don't have to perform multiple functions at the same time. Okay, so here's an example from a Capstone project. If you need a small UAS ISR platform for battle damage assessment, and you need to be able to, functions that are going to be performed are store, deploy, fly, perch, hide in plain sight, and relaunch. Should we use transformational design method? So if you use the different indicator cards that are available at the end of the slideshow, you can step through and rate each value. So here on the right side of this handout, you would indicate, does it use a shared function? I would say yes, there's a fuselage that's a shared function, but it's not a strong indicator, but you might give yourself a score of a 2 or a 3. Does it need to adhere to a variable? No, not really. Does it adhere to a sequence? So are the functions I mentioned sequential? There was store, deploy, fly, conduct ISR. Yes, those are all sequential items. They don't need to happen in parallel. So you can get a high value there. Is storage important? Yes. So you give a high score there. And you add those up and create an average score. On the other hand, you can also take a look at the monomorph indicators. Does this perform a vital function? And you put your score right here on the line. Not necessarily. Is low cost an issue? No, not if we're talking about military equipment. Is limited instruction? No, you would assume that the military operator would have an opportunity to train on using the device. Does it need to perform functions in parallel? No, we already talked about that. Is an aperiodic use item, something that's going to hibernate and then need to turn on right away? No. So its monomorph score would be very low. Its transformation score was moderate to high. So in this system, yes, this system is right for transformation. Now, once you've determined that, you want to go through a transformational design methodology. And fortunately, we have these really cool transformation cards that will help you use this method. So the cards are about yay big. They're scattered throughout the lab in your classrooms. So it's likely that those cards are in your classroom already. If you can't find a set, ask your advisor and ask me. But the cards are really cool. There's 3 cards that show the principles, and then the various facilitators. And the cards have examples of products or items from nature that exhibit that principle or that facilitator. So they help you brainstorm different ideas that would allow you to employ that facilitator or that principle. So in the example of our small MAV, it uses flexible wings, which can fold up around the fuselage and be shoved into a tube. So this is looking at the end view of a tube, but this MAV fits in a 3-inch diameter pipe and can be easily carried and stored. How does it do it? Well, it uses the facilitator of material flexibility. The wings are flexible, and it uses a wrap or fold procedure. We're wrapping the wings around the body, and that is a subset of the expand and collapse principle. So by using the T cards, there are these color codings on them. So in this case, it's green. And if you take a card, take a principal card, any card that has a green line on it like this should facilitate the expand or collapse principle. So you should be able to use it to help create a design or envision a design that would work together to create the functionality that you're looking for. Okay, so to summarize, this is the process for using a transformational design. The first step is you want to decide if you have a monomorph design or a transforming design. Which design method is appropriate for your project? In many cases, transformation can be extremely valuable. If transformation is indicated, then you want to use the T cards, the transformation cards, to create a mind map. So that's the second step. Pull out the cards, spread them out on a table, and start playing with them, see how they fit together to make connections that can help inspire you to envision a transforming design. The last step, as you come up with ideas, fill them in on a mind map to record your ideas and document them. You can add notes to them, your teammates can see them and add their suggestions. Okay, so you put your design problem in the middle of the mind map, create 3 main nodes for the 3 principles, and then create the branches of the 3 showing how transformation occurs. Okay, that's the summary for the lesson. At the end of this slide deck are these handouts for doing the transformational indicators. Here's one here, and the monomorph indicators. So these slides are posted on the Teams page. you can pull them up and print out these slides and work out these indications. We'll expect you at PDR to mention if you decided to use this transformational design methodology or not, and what the indicators told you about that. Okay, that's all we have for today. Thank you for listening. As always, come find me if you need clarification, if you need help finding the transformation cards. And of course, at this stage in the process, we expect that you are finalizing your customer needs, finalizing your design requirements, and you're deep into doing ideation and coming up with lots of concepts. So again, if you need my assistance, come find me, talk to your advisor, work hard, have fun, and go out there and make stuff.